In this video, we are going to do a word problem involving two overlapping sets. So here is the question. It's quite long, so if you want, it might be a good idea to pause the video and give yourself a couple of minutes to write this all down. But I'm going to start to read it together. So the question says that YouTube surveys 500 viewers by asking two questions. The first is, do you prefer a long chunk of ads at the start of the video or 2 to 3 smaller ads interspersed throughout? Question 2 is, have you seen an ad for Cheetos in a YouTube video recently? All right, then the question says, 360 people preferred a longer ad chunk at the start, and 100 of those who had seen a Cheetos ad preferred interspersed ads. If there are twice as many people who prefer interspersed ads and had not seen a recent Cheetos ad as people who preferred chunked ads and had seen a Cheetos ad, how many viewers preferred a longer ad chunk and had seen a Cheetos ad? I guess I should have a question mark here then. Okay, so a lot of words, but like I mentioned before, it might be a good idea to pause the video for a couple minutes to write this stuff down. Okay, so I'm going to start to get into it. All right, so to get us started, it's going to be a good idea to assign some labels to our sets. So let's call our sets something. So because there's two questions being posed here, and the numbers that the question gives us, like 360 or 100, they refer to the number of people in various sections within those sets. We should call the set something like A or B or something. Okay, so the first question is talking about, do you prefer a longer ad chunk or no? So maybe let me call L. I'm going to say this is a set, so I'm going to put the set notation. It's a set of people preferring a long ad chunk at the start. I'll just say long ad chunk. And then I'm going to let C be the set of people who've seen a recent Cheetos ad. All right, so I want to begin by identifying, well, what is this question ultimately asking us to find now? So the question, I've actually written it in green here, asks us how many viewers preferred a longer ad chunk and had seen a Cheetos ad. So the word and means we're looking for an intersection. So longer ad chunk, that's L, that's the set L, and had seen a Cheetos ad, that's the set C. So the question is asking us to find the number of people in L intersects C. So next, I'm going to go to the next page because I'm running out of room a little bit on the previous one. Let's draw a Venn diagram. That was one of our strategies from the last video. Draw a Venn diagram. Okay, so I'm going to draw a circle for the set L and a circle for the set C. And those are going to be contained in my universal set, which I'll draw a rectangle for. And our strategy with these is we usually want to work inside out. So work inside out. And I'm going to start by labeling the section at the intersection. That is the most inside part of this. I'm actually trying to find the number of people in the intersection, so I don't know what that is. So I'm going to assign a variable to it. I'm going to call that X. I am looking for the number of people in that intersection. So if I go back to the question and I look at the numbers that the question has, it says that 360 people preferred a longer ad chunk at the start. So that means L should have 360 total people in it. So in the whole circle that I have for L, that whole thing should have 360 total. This says 360 total in here. And that includes the intersection region. So that's why I can't just put 360 here, because that's assuming that that's outside of the intersection. So I have 360 total in that circle for L. So to figure out how many people are in this section, I know that if I add up x plus whatever that missing number is, that needs to be 360. In fact, let me just write a variable there. Like if I call the number of people in the set A, I get x plus A is 360, and I could isolate for the A by subtracting x. So A is 360 minus x. Okay, so I can replace A with 360 minus x. 360 minus x. That's how many people are in that section. So next, going back to the problem, it says that 100 of those who had seen a recent Cheetos ad, so that means within the circle for C, preferred interspersed ads. Well, interspersed ads means you're not in L. You're in L if you prefer longer ad chunks. So the 100 is talking about the people who are in the C circle, but not in the circle for L. So the 100 is over here. You're in the circle for C, but you're not in the circle for L because you don't prefer a longer ad chunk. All right, there's one final piece of information that the question gives us, and that is if there are twice as many people who prefer interspersed ads and had not seen a recent Cheetos ad as people who prefer chunked ads and had seen a recent Cheetos ad. So let's break this down. So they're saying there's twice as many people in one section compared to another section. So here's the word twice, and it's twice the number of people who prefer interspersed ads and had not seen a recent Cheetos ad as, there's a connecting word, and then I have another set described after that. But let's focus on the one that I've underlined in red. So this is the number of people who preferred interspersed ads and had not seen a recent Cheetos ad. Well, that means you are not in L and you are not in C. So you're not in either circle. So going back to my picture, that is talking about this region. So that is talking about this region out here. So let's go back to the word problem now. So the question is saying there's twice as many people in that red region outside of both circles as there are people who prefer chunked ads and had seen a recent Cheetos ad. Well, what section is that? People who prefer chunked ads and had seen a recent Cheetos ad. Well, that is in the intersection. You're in L and you're in C. So in my picture, that is in this region. So the statement is saying there's twice as many people outside of both circles as there are in the intersection of the two circles. So if I said that there's X people in the intersection, that means there's got to be twice as many outside of both circles. So I would write 2x out here. All right, so we really had to translate those words into algebraic values like this. So now I have labels in every single section here. So I can note that the question tells me how many people there are total in the universal set. It says there's 500. So if I add all these numbers up, if I add up the 360 minus x, added to that x in the middle, added to that 100, added to 2x, this should be equal to the 500 total people who are surveyed. So I know the minus x cancels with that plus x, so I end up with 460 plus 2x equals 500. And if I subtract 460, we get 2x equals 40. And then dividing by 2, we get x equals 40 divided by 2, which is 20. And that's what the question was looking for. Let's just write a phrase for that. There are 20 people who prefer a longer ad chunk and have recently seen the Cheetos ad, which is what the question wanted. So in terms of our goals for the section, we finished our first goal, which is focused on counting the number of elements when we have two overlapping sets. So when we have a union and the A and the B are not disjoint. In the next couple of videos, we'll talk about how to do similar problems, but when we have 3 overlapping sets. So we're going to up the difficulty a bit.